frog. And look, so, you know, if there's any particular details that people want associated with this program, please don't hesitate to send me an email later. All right. So just by way of general overview, there are two Corroboree frog species, what we call the Northern Corroboree frog and the Southern Corroboree frog. And they're found in an area of southeastern Australia. The majority of their distribution is within a national park called Kosciuszko National Park, but they're also found in Namadgi National Park and some other small state forest areas to the north. So Corroboree frogs in general, they breed in very small pools at relatively high altitude, and these are sort of seasonal pools that during the summer breeding period typically don't have water in them, and the males occupy nests in the vegetation around the edges of these pools. That's where they call from. If they're successful at attracting a female, that's where the eggs are laid. And so within the nest, you'll have this male that well, you know, starts to accumulate anything up to about 12 to 13 egg clutches from different females, depending on how successful he is. And he'll stay in there during the breeding season, continue calling, continuing to amass eggs until he eventually thinks the season's over. He leaves. The eggs then develop through to a hatching stage. It's then in the autumn and winter rainfall period that the pools fill up, the nest sites are flooded, and it's the flooding that stimulates the eggs to hatch. They hatch, move into the pools, and they're then a pretty standard looking tadpole, free swimming and feeding. And it's not until they start to get towards metamorphosis that they develop those colours that the Corroboree frog's known for, and then eventually, you know, moving out of the pools and entering their terrestrial phase of life. Like many frogs around the world, the key threat to these species is the amphibian chytrid fungus. I'm sure most of the readers are very familiar with the pathogen. And just by way of sort of potted history of the program, so for the first, you know, dozen years of the program, there was some intensive monitoring which identified that we had a real problem with our Corroboree frogs, but we didn't really know what the key threat was. And so the recovery program for this species had been initiated and was in full swing prior to understanding what was causing the decline. And that was an interesting phase. Many of you out there were probably doing similar things at that time and sort of were familiar with a lot of the debates going around what was causing global frog declines. It created an interesting time for recovery programs, at least in Australia. But one thing that was definitely clear to us, despite not knowing what the key threat was that the species was in an ongoing and unstoppable state of decline, and that if we wanted confidence that we weren't going to lose this species altogether, we had to initiate a captive breeding program. And so, above all else, we knew that, well, if we don't get the captive breeding program sorted, then we may lose the species. And so, I guess from an early stage, even prior to the threat being known, you know, we had this clear objective of get the captive breeding colony worked out, and then ultimately, you know, that's going to lead to a reintroduction program. But let's not worry too much about the reintroduction program down the track. Let's just be very focused on the task at hand, which was getting that breeding program going. And I think that's actually an important point regarding these sorts of recovery programs. We're often making decisions in somewhat of a knowledge vacuum. And in many cases, despite being in that knowledge vacuum, it's still very clear what our next key task as managers are. And so, you know, this graph here showing this sort of flow diagram is just sort of pointing out that, you know, we knew we had to develop the captive assurance colony, but there was all this other research and work going on, which was providing the necessary knowledge and baseline information that would allow us to, you know, successfully establish that captive assurance colony, but then hopefully also lead further on to further success in the program. Moving right along, you know, where we're kind of at now with the overall program. So this schematic diagram kind of summarizes where the program's currently at, and it's all centered around having these captive colonies of the Corroboree frog, which provides our assurance that we're not going to lose them, and then our efforts to get them back into the wild and maintain them in the wild, and maintain them in the wild in different ways, and I'll talk more about that in a moment. But you know, the combination of the captive colonies plus our efforts to keep them in the wild provides, I guess, the core of the program from which everything else operates around that, and that's with regards to you know, being strategic about the program, what sort of research we're currently engaging in to you know, hopefully progress the program to the next stage, etc. So just reiterating that point about the captive assurance colony, and look, I'll comment about this a little bit later with regards to lessons learnt in the program, but you know, in many respects for these sorts of programs, scale is everything. Scale is what allows you to have you know, hopefully more capacity to do your introductions. Scale is what's required to have a successful strategy for maintaining genetic variation in the program. And hopefully also with scale comes diversity of locations where you're holding the animals, which for a whole range of reasons is really, really critical too, including spreading your risk. But you know, we've obviously moved on to knowing in a lot of detail what the threat to the frog is and what's caused the decline, but we've still got a long way to go with regards to understanding how we can adequately mitigate this threat and ultimately sort of result in self-sustaining wild populations, which is our ultimate management objective. But you know, in heading in that journey, what we really need is you know, a robust program that's not going to be too susceptible to, you know, various things that could cause problems along the way, and I'll talk about that more later. So just getting to the point about understanding the threat and thinking about, so we've got our captive assurance colony, how can we get this species also maintained in the wild, not just in captivity? You know, and I talked quite a bit about this in my previous presentation, but one thing we understand now with the Southern Corroboree frog and the Northern Corroboree frog is that, yeah, sure, BD is the key threat, but I guess the key part to the picture with regards to the host pathogen dynamics of chytrid fungus and Corroboree frog is the role that's being played by a non-susceptible reservoir host species, the common eastern froglet. And really what we know now is that it really is that common eastern froglet that's facilitating the pathogen's capacity to cause ongoing decline towards extinction. Where you don't have the common eastern froglet, the Corroboree frog's doing much better, and we have a situation in part of the landscape where that's what's happening for the Northern Corroboree frog, and I'll make mention of that a bit later. So our strategies to get Southern Corroboree frogs back in the wild, persisting in the wild, really does, you know, the overall theme or strategy is to try and get the species back in the wild in ways in which it avoids contact with the common eastern froglet. and we're kind of spreading our efforts with regards to this strategy at the moment. We've got sort of 4 key reintroduction techniques that are currently being trialled / developed. First one being getting the frog back within its historic range, and we're doing that by releasing into artificial ponds. And the artificial pond is a technique that we're developing to at least remove part of the life stage of the frog from contact with the common eastern froglet. And then we've got these other techniques we're trialling, which I guess essentially are putting southern Corroboree frogs into a new landscape. In 2 cases, that's a new landscape that we've created within enclosures, large and small enclosures, but then also putting Corroboree frogs into artificial bogs that we've created, and we've built, and we're starting to try and build these bogs in part of the landscape where we don't have the common eastern froglet. So maintaining Corroboree frogs back in the wild, putting them into artificial ponds. So that's being done by putting the eggs, instead of putting the eggs back into the natural pools, we put them into these tubs, and these tubs are in spots and positioned such that they can't be accessed by the common eastern froglet, just by virtue of the fact that the tubs are slightly raised out of the ground. The common eastern froglets can't get up and around and into those tubs. And so that ensures that the tadpoles make it through to metamorphosis without being infected by the chytrid fungus. It also ensures that during drought years that we don't have early pool drying causing the tadpoles to die. We can artificially maintain the water in those tubs to ensure that drought doesn't cause that high level of mortality. And so this technique is successful at keeping Corroboree frogs in the wild alive, but the technique is limited. And the reason for that is that I guess much of the infection and associated mortality, as we all know, is occurring post-metamorphosis. And so while we can reduce levels of infection prior to metamorphosis and just on metamorphosis, we're still limited in reducing that infection that happens after those stages leading up to sexual maturity, which is obviously contributing quite substantially to the overall impact of chytrid fungus on the species at the population level. We've also been trialling releasing adults, and there's a level of success in doing that too. But just want to make a point with regards to that, that it is interesting. Initially, we were interested in the question of, what are the relative efficiencies of releasing eggs versus older frogs. The issue with releasing older frogs is they might have greater survivorship, but they cost a lot more to produce. And where we've kind of got to now with that is that producing eggs is so much cheaper because you don't have to worry about all the facilities and costs associated with rearing after the egg stage, that it's so cheap that really it's worth our while focusing on that life stage at least at this point in time, to try and perfect it, because well, for a couple of reasons. One is it is so much cheaper than releasing other life stages. The other is that we're maintaining our captive assurance colony to prevent extinction. In many respects, the eggs produced from that captive assurance colony are a byproduct of the assurance colony. And so, and our assurance colony currently has a strategy to maintain the majority of existing generation for at least up to the next 50 years. And so we feel as though time is on our side. We do actually have quite a few decades up our sleeve to try and perfect some of these techniques. And so given how relatively efficient the egg release stages are, it's very much a strategic management focus to get that egg release perfected because of the benefits that it provides to the program in terms of efficiencies. The other big focus of the program at this stage is creating new environments, and in this case, creating environments within a fenced-off area that keeps other frogs, other potential reservoir host species out, and the idea being that these will be, I guess, disease-free nursery sites in the field that ultimately we hope will assist with our maintenance of genetic diversity broadly, but also assist in maintaining field fitness of our assurance colony. But in addition to that, hopefully they'll be productive and be nursery sites that we can essentially harvest from and use for other aspects of the program. That is working reasonably well at this stage, although yeah, we need to perfect the technique a bit better, but we are getting reasonable survivorship and breeding within these enclosures, such that we're very confident that we're going to, you know, achieve our ultimate goal of having these productive nursery sites using this approach. We're also looking at developing the same sort of technique, but using much smaller enclosures. The potential benefit of the smaller enclosures is they're easier to construct. You're spreading your risk in that, you know, if chytrid fungus gets into a large enclosure, we're likely to lose the whole colony, whereas we have that colony spread amongst a bunch of different small enclosures. You're not losing all of them if you have chytrid fungus outbreak. And also having replication, greater replication will assist when we start using these enclosures for different experimental purposes. In addition to this, we've got other sort of research going on to assist with all these sorts of questions. In particular, some of the work going on at the University of Wollongong, looking at how can we use assisted reproductive technologies to assist in breeding and genetic maintenance of the Corroboree frogs, and and there's obvious benefits to this sort of having this sort of technology available to the program as well. So look, I just want to sort of touch on some of the broader lessons learnt that I think are applicable to these sorts of recovery programs for threatened frogs, but I guess, you know, they're probably applicable to recovery programs for critically threatened species more broadly. And firstly relates to you know, some of the sentiments that were going around and are still going around within the sort of conservation biology sphere. And so in Australia, at least, we had a period that probably lasted 10 or more years, but is still being felt, where some of our sort of more higher, sort of more esteemed conservation biologists were promoting this idea of triage. And so they were promoting this idea that for some species that were perceived too expensive and too difficult to save, that we should just let them go extinct. You know, and the idea being that if you do that, then the resources saved on that can help other species where there's a greater chance of survival. Now, there's a whole range of reasons why, you know, I believe this is a poor way to sort of view our conservation biology, and it's certainly created a lot of problems for pursuing the recovery of species like the Southern Corroboree frog. And so my advice to anyone who's sort of being challenged by this sort of idea is that stay focused. What we've seen in Australia is that this idea has, albeit that the repercussions of this idea is still felt, the idea that this is acceptable we have moved on from this, and it's no longer perceived as acceptable. And but it was a difficult phase of the program, riding out the time when we were faced with a lot of criticism and a lot of people saying you should just let the species go extinct. Your efforts aren't justified. And I mean, even though we still can't mitigate the chytrid fungus, the way the program is developed, which is now developed through to a very robust and efficient program, there is no justification from a cost-benefit perspective to let something like the Southern Corroboree frog go extinct. And so that is something that will undoubtedly happen for other programs if you just let them be pursued for long enough. Another thing that I think is really valuable with regards to implementing these sort of programs is being progressive and innovative. I think all of us need to keep thinking outside the square a little bit. Things like the enclosures. We were always told at the start when we first started talking about this, lots of people said it won't work, it's not worth pursuing, blah, blah, blah. But what we've found is that it's been very worthwhile to pursue. We went into it not really knowing what we would find out, and not really having any real assurance that it would ultimately lead to some level of success for the program. But I guess just thinking independently and thinking creatively, I think, is a really important thing that people need to do. We should really promote the idea of risk-taking and trialling different things in this sort of game, because I really sort of think that there's different techniques that might be out there that'll be real game changers for a lot of the sort of programs we're trying to implement. Undoubtedly, one of the biggest challenges for this sort of program is standing the test of time. So as a manager of this program, well, to be honest, my head is thinking that the program is probably going to outlast my career. I'm expecting I'd like to think that I'll still be pursuing frog conservation at least for the next 20 to 25 years in a professional capacity. But if I think about it objectively, I suspect that a lot of the programs I'm currently managing won't have reached their ultimate endpoint within that next 20 to 25 years. Really, the programs need to be ongoing beyond that. I'd love it if it wasn't the case. I'd love to see ultimate success within my career, but chances are that's not going to be the case. So I think thinking about how your programs stand the test of time is really critical. Thinking about what things will make a difference in terms of enhancing robustness and efficiency of the program is really critical. And so just with regards to managing for longevity, some of the challenges that I'm trying to work around is not having key components relying on short-term funding. And a key one to that has been the absolutely critical and fantastic contribution that the zoo institutions are providing to this program, in particular Taronga Zoo and Zoos Victoria. And so Michael McFadden and Dion Gilbert really are providing what is the critical resourcing and contribution to these programs that ultimately will result in success of the programs, in my opinion. Thinking large scale, but large scale with efficiency. And this boils down to the most expensive component of the program is undoubtedly the breeding and rearing of frogs. You want to be trying to do this on as large a scale as possible, but it's not going to be sustainable if it requires a massive resource base for it to happen. And so thinking about ways to have that large scale but with efficiency really is critical, and that's where those field enclosures come in a big way. If we can get those field enclosures being really productive, then that's going to really tick that box of large-scale breeding and rearing at very low cost. Maintaining populations in the wild, for a whole range of reasons, it's probably not going to serve the program well if we just fall back to we've got these things in captivity. maintaining them in the wild is critical for, well, I think is critical for maintaining field fitness, which ultimately in the future is going to be really important. But in addition to that, just perceptions and capacity to move forward with the program is really reliant on still having frogs out there in the wild. And that's for a whole range of reasons. As I said before, progressive and innovative, and undoubtedly the other big thing about it is maintaining the strong partnerships among recovery team members. And you know, and as I sort of mentioned just before, the key one for this program is our strong partnership with the zoo institutions. And part of that is about the sort of capacity building for the program. But in addition to that, it's actually also about riding out the ebbs and troughs of resource availability. So what we have seen over the last 30 years with this program is that at different times, different partners have been able to carry you know, the lion's share of the resourcing of the program. And so over time, the program's well resourced, but that's only come about by virtue of the diverse partners that are involved. Just thinking about, you know, the resourcing of the program. And so currently one of my big challenges is ensuring that the key aspects of the program aren't funded by short-term funding cycles. They're actually funded by recurrent ongoing budgets. Big part of that's the zoo component of the program, and they bring that to the program. But in addition to that, within our government agency, ensuring that it's ongoing funding that's paying for the program, not short-term funding or grant cycles, because that just locks you into that difficult cycle of trying to achieve resources through the grant process. Spreading the risk. I can't emphasise this more, you know, more importantly. I think early in the program, in my head, it was, you know, I was sort of thinking, yeah, look, problems can happen, but you know, the likelihood is relatively small, so you know, it's not something we should worry about too much. Whereas now, what I've seen is the likelihood of something happening at any particular point in time is probably small, but over time, the likelihood of it happening is not small at all. We've had various things happen in the program that have demonstrated to me that it's essential to spread your risk, particularly with regarding to your maintenance of your assurance colony, because things will happen that if it happened to you, to the lion's share of the colony, you would be left in a very difficult situation. And so, you know, the examples I have for this program are trees falling over and taking out our enclosures, wildfire. So we've had wildfire events that have burnt right through the entire range of the species, which has cooked the majority of the animals that we had in the field at the time. But in addition to that, we've had three major mortality events in captivity. Well, actually, it's 4 major mortality events in captivity that, had we had all our eggs in one basket, we would have compromised our capacity to maintain a genetically robust population into the future. And so this has been a combination of well, in 2 cases, fire burnt out colonies. Then we've also had electronic failure, which cooked one of the colonies that were in a climate-controlled room. And we've also had unknown sources of mortality causing death of a large proportion of the colony in some of the stock. And so, anyway, can't emphasise enough the need to spread your risk if you're at that end of the program where you're needing to maintain the species in captivity. And of course, the diverse partners, absolutely critical. And for us, that's particularly the husbandry institutions, but also some of our academic colleagues at the universities. So just going to briefly touch on the northern corroboree frog as well. So the northern corroboree frog is in three sort of, I guess, distinct evolutionary units or management units, and the two management units to the east, so to the right of the screen there in Brindabella National Park and Namadgi National Park, they're essentially in the same situation that the southern corroboree frog is in, and we have intensive large-scale captive breeding programs and reintroduction programs for those ESUs, those management units. But then for the larger management unit, we still have parts of the wild population for that management unit that are still persisting in a more robust fashion, and leave us with a bit of hope that at least part of the historic range of the northern corroboree frog might persist in the future. And the key reasons for this, well, part of the range where the northern corroboree frog occurs, for various interesting reasons, the habitat is not suitable for the common eastern froglet, which, as I mentioned earlier, is the key reservoir host. And so what we see there is that the northern corroboree frog is persisting in a more robust, self-sustaining sort of fashion, and so hopefully that persists into the future. But what we do have with regards to northern corroboree frog is other threats that are also, in particular, threats that are impacting the habitat of this species, and so that's where our sort of management focus can but then hopefully provide some assistance to help this species. And so in Kosciuszko, this is around feral horse impacts, and so we've got a lot of difficulties managing feral horses in Australia in some places because of cultural heritage perceptions. People who are very fond of horses don't want to see horses managed, don't want to, or in particular, they don't want to see them culled, and so that's creating a few problems for the program. And then in the state forest areas, we also have some issues associated with some people releasing their stock into corroboree frog habitat, and so there's a few management issues associated with that. But and so the impact that these sort of feral animals or stock animals are having is through disrupting the breeding habitat. And while they're not the key driver of decline, they are an issue that we need to manage if we want to maintain good breeding habitat for this species. But they're just kind of issues that we need to deal with regards to maintaining good habitat for the species. Ultimately, the decline of the northern corroboree frog and southern corroboree frog is being primarily driven by the amphibian chytrid fungus, and recovery in the future is really going to be reliant on the development of that technique that, you know, I guess that silver bullet that we're all looking forward to in the future, which is that we'll have the capacity to directly mitigate the chytrid fungus in some way. And you know, and I guess there's lots of discussion and papers out there as to how that might come about. My gut feeling is that it's probably going to require the development of some sort of technique to enhance the immune response to chytrid fungus. But I guess, you know, it's probably early days in the research and development of these sort of techniques, and I look forward to seeing how things progress in that space in the future. Thank you.